Hello and welcome to this video on absolute value equations. So this is section 7.3. We're going to break it up into two parts. There's going to be the first part, which is going to be on linear, and then we're going to do a second part which will be on the quadratic functions. So before we begin this lesson, what I'm going to do is I'm just going to quickly go over a question from last day. So this was actually number 13 from our textbook. So it said, write the piecewise function for y equals the absolute value of x squared minus 2x minus 8. So this is quadratic. We can tell it's quadratic because it has x squared. And then it said we wanted to sketch the graph of this function. So I'm going to first show all my work, and then I'm going to walk through and kind of explain it. So there's all the work for this one. So what we should do to get some points for our graph, we wouldn't be able to just graph this magically. We got to get our x-intercepts and our y-intercepts. That'll give us some points, and then once we have those points, then we can figure out where our graph is going to go. So x-intercepts you just sub in when y is equal to 0. So this y is going to change to 0, and then to get rid of the absolute value sign, it's just going to disappear, and then whatever's on this side you took the plus or the minus of. So plus or minus of 0 is still 0. And then this is just a normal quadratic equation that you can factor and then find our two x-intercepts. So it's at -2 and 4. So we got -2 and then at 4. So the y-intercept, this is always easier. This is when x equals 0. So x in here is going to change to a 0. So 0 squared minus 2 times 0, those will be gone. You'll just get -8. So -8 in absolute value is just 8. So you know the y-intercept is up here at 8. And then if you wanted to get some other points, what I did is I did when x equaled 1. So I plugged that in up here, and I got out this value. So I got 9. And on my graph, if x is 1, that's right here, y is 9, that's up here. So that just gave me my kind of vertex point of this middle. So now that I can see what my graph looks like, I kind of have this parabola here where it's pointing down, and then I have this parabola on the outside where it's pointing up, but it is only kind of this outside part and this outside part. So let's write this as a piecewise function. I'm just going to do this down here. So it's going to be y equals, and then we're going to write our function, which was x squared minus 2x minus 8. So x squared minus 2x minus 8. And then we're going to write the exact same thing again. And then put the second one in brackets and put a minus in front. And then just put your big curly bracket in front to show it's kind of these two different pieces. And then we just got to state the domain for each one of these. So this one is quadratic, where the number in front of the x squared is positive. So that means the parabola points up. So the parabola that points up is this one right here. So I can see that is when x is greater than or equal to 4, and when x is less than or equal to -2, because that's this part pointing upwards. So we're going to write that. That was when x is greater than or equal to 4, and when x is less than or equal to -2. And then this part has a negative, so if you brought the negative in, we're going to have a negative in front of the x squared, so that means it's a parabola pointing down. So the parabola that points down we can see is this, and that goes from -2 up to 4. So -2 up to 4. So we can write down here, it's going to be x, and it's going to go from -2 to 4. And remember, if these ones have equal signs, then these ones can't. Okay, so now that we're done with that little review, we're going to move on to our notes for today. So our steps are as follows. First, we're going to isolate the absolute value on one side of the equal sign. So like this one, that would already be done. Same within this next one, actually. We already have the absolute value on one side by itself. Step 2, you're going to allow each expression inside an absolute value sign to be positive or negative. So we're going to change whatever is on the other side. It's going to be both a positive and negative. We kind of talked about that a little bit in the last video. Then you're going to solve both those equations how you normally would. And then after, check for extraneous roots to make sure that you don't have a solution that actually isn't a solution. And then lastly, you can graph both sides of the equation and find the points of intersection. And for that, when we do it here, for this class, you're allowed to use your calculator to figure out some points to help yourself graph it. So I don't really expect you to create like a whole table of values and then plot all those points because it's quite time consuming. Okay, so let's get into this first one, number 1. So we have the absolute value of 6 minus x, and that equals 2. So our steps, we first wanted to isolate the absolute value. We've already done that. Then what we needed to do was we're going to make whatever is on the other side a positive and a negative. So I'm going to write 6 minus x with no absolute value sign. It's now gone. It's going to equal a positive 2. And then I'm also going to have 6 minus x, and this is going to equal a negative 2. And then these two equations I'm going to start to solve. So isolate and get the x by itself. So I'm going to, with this left one, I'm going to subtract a 6 from both sides. So when I subtract a 6 here, those will disappear. And then on the other side, I'm going to have 2 minus 6. That's going to be negative 4. And then I'll divide both sides by a negative. So I get x equals a positive 4. For the other one, we can minus 6 again with that one. Minus 6. Those 6's will cancel on the left. And then I have minus 2, minus 6 on the right. So that's just negative 8. And then divide both sides by a negative. So I get x equals 8. So now that I have those two solutions, what you should do next is verify or check for extraneous roots. So I'm going to do that quickly right here. So verify. And first we'll do an x equals 4. So we had this 6 minus x in an absolute value. This should equal out a 2. So we got 6 minus, and then it was a 4. And we're taking absolute value of that. 6 minus 4 is 2. And then when you take the absolute value of 2, you're going to get 2. So that is going to be correct. We can do the same thing with this other one. So it's going to be 6 minus, and we got an 8. So 6 minus 8. This should equal out a 2. 6 minus 8 is negative 2. And then when you take the absolute value of negative 2, you get positive 2. So we get 2 equals 2, which is also true. So both of these solutions are good. Both have been verified. Now for the last part, which is going to be our graph. What I'm going to do is I'm going to pull out our graphing calculator, and I'm going to show you how we can do this. Again, I said for this class, you're not going to have to like make a whole table of values and plot it. You can kind of use your calculator to figure out some points for yourself. So I'm going to move it over here so we can still see everything. So what you can do is go to y equals. So we'll click y equals, and then we're going to enter in both of these sides. So I'm going to have the absolute value of 6 minus x in y1, and then for y2 I can just put in a 2. So to get this absolute value sign, what you got to do is you got to click math, and then it's in the number. So you'll click over, and then it's the first one here for me. Yours might be in a different order. But we'll click that, and then it'll put in an absolute value sign. And then we just have to put in 6 minus an x into there. Okay, and then we can scroll down to our y2, and we're just going to put in 2. And then once we have those, what we can do is we can click graph, and it will graph it for us. So I can see there's kind of the V shape. That's for the absolute value sign, because none of these values can go negative. They got flipped up, and now they're going up here positive. And then this is the line y equals 2. So it's just a horizontal line, and I can see I got 2 intersection points, so 2 crossing points. And to find where those cross, what you can do is go second, trace, and you want to find the intersection. So number 5. And then what you'll do is you'll scroll over closer to the point, and then you click enter. And then this time it'll jump to the other line. And if you wanted to scroll closer, you could. Just make sure you're close to that point. Click enter. And then one more time for it to guess, and it'll find where it crosses. So we got 4. So which was one of our answers, x equals 4. You could do the same process, just move closer to this point, and then you'll find that that one is x equals 8. So to help yourself graph this picture, what you could do is you could go to your table, click second, and then graph. That gets you to the table. And then you could use these points to help plot some points onto your graph. The good thing about linear equations, when you take the absolute value of them, the graphs are quite easy. It just gives you that V shape, so you don't need too many points. So let's just grab some of these points and we'll plot those on our graph. So let's take 0 and 6 and we'll plot that on. So that is going to be right there. And let's also do at 6. So 6 we're going to get 0. So that is down over there. And then let's do one more. Let's scroll down and we'll do at 7. At 7, we get a 1. So our absolute value is going to go through those points. So we're going to have a line that goes like this towards the left, then we'll put an arrow on the end of it, and then we're also going to have a line that goes to the right through that point there on the right side. And then lastly, to get the other function, the y equals 2, that's just a horizontal line at a height of 2. So I can draw a line at a height of 2, that's right here, and it's just going to go horizontally through, and then I can see my two intersection points. They are just right here and here. And then once you have your graphs on there, usually it's a good idea to label them so that you can distinguish them. This one is, we called y2, and then this one was the absolute value function. That was 6 minus the absolute value of x. So that one is done. We can move on to number 2 here next. So number 2, we have the absolute value of x plus 5 equals 4x minus 1. So the absolute value is already isolated, so we can just take the absolute value, set it on one side by itself, and then on the other side we're going to take the positive, so that's 4x minus 1, and then we're going to do a second one where we take the negative, so it's going to be negative and then 4x minus 1. Make sure you put that in brackets because the negative is going to distribute into the brackets. So let's solve this one on the left here first. So to solve that, we'll get all of our x's on one side because it's linear. So I will subtract an x from this side, subtract an x from this side. My x's will cancel. And then I'll add a 1 on this side and add a 1 on this side, so I get rid of the 1's on that side. So now I have on the right 4x minus x, that's 3x. And on the left, I have a 5 plus 1, that's 6. And then I can take both sides and divide by 3. And then those 3's will cancel. And then I'm just going to switch the sides as I go to this next step. We got 6 divided by 3, that's just equal to 2. Looking at this next one here now, so we're first going to distribute into the brackets. So we'll rewrite the left-hand side. And then when we bring that in, we're going to have negative 4x. And then with the other one, we got negative and a negative. So that's actually positive 1. So again, we're going to get all the x's onto one side. So I'm going to add 4x. I'm going to move all my x's over onto the left. So those will cancel. And then I'm going to minus a 5 and minus a 5. So my 5's cancel. And then I get out of this, on the left, I got an x plus 4x. That is 5x. And on the right, I got a 1 minus a 5. That's just negative 4. And then divide both sides by 5. So those 5's will cancel on the left. And we get x equals negative 4 over 5. So now what we should do is we should verify our answers to make sure that they are correct. So I'm going to verify using our calculator. If it said to verify algebraically, you should be doing it by hand, like how we did it up here in the pink. So I'm going to bring out my calculator and we're going to type in these two new functions. We're going to type in the absolute value of x plus 5. So I'm going to go into here and we're going to put in x plus 5. And then for our other one, we're going to put in 4x minus 1. So that is 4x minus a 1. And then we can click graph. So there's our absolute value. Everything's positive. And then here is our line. That is the line 4x minus 1. It's got a slope of 4, a y-intercept of negative 1. That's why it crosses down here at negative 1. And I can see that that line goes upwards and it only crosses here once. It doesn't cross twice. If you wanted to go zoom and then zoom out, that's zoom number 3. You can see there's the absolute value, and then this line's going to come up, and it's still not going to cross. No matter how many times you zoom out, it's only going to cross once. So let's find what this point is here. We'll go second, trace, intersect is number 5. This is where they cross. And then you can click enter, enter, enter. It'll find the closest point. So enter, enter, enter. And we get x equals 2. So that crosses at 2. So that is this answer here. So this one we're going to have to cross out and say that that is extraneous. And then now that we have that, we can start to graph this one. This one I'm going to kind of do it by hand because it's actually not that bad. So let's first graph this one. So we're going to graph, we'll call it y1. It's the absolute value of x plus 5. Now, if you graph just y equals x plus 5 without the absolute value, the y-intercept is right there. It's a 5, so I'm going to put a point right there. And then the slope, whatever's in front of the y here, that is your slope. So your slope, really, there's a hidden 1. So your slope is 1, which that's just 1 over 1. So our slope is 1 over 1. So this is going to rise 1, move over 1. Rise 1, move over 1. So we can see that we get these points right here. So I'm going to erase those hops that we had. And then what I can do is I can draw my line going through those points down to where it would cross on the x-axis. And that was going to happen at 5. And then any of these points that were going to be going negative, they're going to have to reflect and go positive because we take the absolute value of them. So rather than going down 1 and over 1, it's going to go up 1 and over 1, up 1 and over 1. So we're going to get a line that goes like this. And then to graph our other function, so that was y2, I'm going to do it in a different color so we can see it. So that's 4x minus 1. So that has a y-intercept of -1. So it's going to cross down here at -1. And then the slope is whatever's in front of the x, which is a 4. And really that's 4 over 1. So you're going to rise 4, 1, 2, 3, 4, and then move over 1. So we get another point. And then you're going to rise 4, 1, 2, 3, 4, and then move over 1. So just erasing those hops, we're going to get those points right there. And then we can take our ruler and draw our line going through those points. And then draw our arrows at the end of the line. So we can see with this one, it crosses right here. And that was at when x equals 2. It was over 2. So x equals 2. The last one we got here now, number 3. So we got the absolute value of 3x minus 4 plus 12 equals 9. So we first wanted to get the absolute value by itself. So we're going to subtract 12 from both sides. Those 12s will cancel. So we got the absolute value of 3x minus 4 equals, and then we got 9 minus 12. So that's -3. Now just looking at this, can you guys think of a number that when you take the absolute value of it, you're going to get out a negative number? So there's no number that when you take the absolute value of it, you'll get out something negative. Because remember we said absolute value, it's going to turn it into something positive. So I can see right here, there's not going to be any solution with this. So as soon as you see that, you can stop and say that this has no solution. If you wanted to continue solving this and take this and drop the absolute values and then make this a positive and a negative, kind of like how we did with the other ones, you could do that. You'll get 2 answers, but neither of them are going to verify. Neither of them will be correct. So let's get our calculator out and we'll graph this one and see what this one actually looks like. So we'll go to y equals, we can put in the absolute value of 3x minus 4. So that was 3x minus 4. And then it was also plus 12 on the outside of that absolute value. So put plus 12. And then we can do our second one, and this was just a 9. So we can clear the side, put in the 9, and then we'll graph this one, see what this one looks like. So there's our absolute value, the V shape. And then our horizontal line, y equals 9, that does not cross. You maybe can't see it, so I'm going to zoom in. I'm just going to click zoom, and then option number 2 is to zoom in. And then I'm going to scroll up a little bit just to make sure that we got the point in our view. So we can see they do not intersect, they do not cross. So to help ourselves now graph this, what we can do is we can go second and then click graph. That'll get us to our table. So the first one we could draw is y equals 9. This one's going to be easy. It's just going to be a horizontal line that goes across at 9. And then to graph the absolute value part, so that was the values in this one, we put it into y1. So I'm going to go and see what x is at 0. It's 16, so I'm going to plot that point here. So at 0, we are up at 16. This right here is 10. This is 15, so we are just a little bit above that, so we got a point right there. Our lowest point on the graph we could get by finding the minimum. So I'm going to do that. We'll go second, calc, and let's find the minimum. So that's number 3. And then we'll get on the graph and ask for the left bound. So you got to get on the left side of the minimum. So that's over here somewhere. Click enter. And then ask for the right bound. So you'll go to the right side of it. Click enter. And then it says, do you want me to guess in between? And we'll click enter. And it'll find that point. So it happens at 1.33 and it's at 12. So that is going to be somewhere right about there. And then to get one more point on our graph over on this side, I'm going to go back to my table. So second graph, and I'm going to find when it's at this line. So that is 5 over. So at 5 over, it's at 23. So we're going to be up. This is 10, 15, 20. So we're going to be just above that. So we can put a point about there, and then we can draw our lines going through those 3 points. And then we're just going to label that one. That one was our y2, and that was the absolute value of 3x minus 4, and then plus a 12. So to get your graphs, make sure you're using your calculator. You can look up some points in the table of values, plot some of those points. You don't need lots of them, just kind of a few so that it's at least accurate, and then you get your graph. So our textbook questions we got here just at the bottom. So we're on page 389, and we got those 4 questions right there.